Hello, everyone. Thanks for joining us today. Let's wait for just one more minute uh, and then we'll start. Thank you. Okay, so let's start. I hope everyone is keeping safe. You and your family members are all good. This has been a tremendous year, 2020. As you all know, we have been conducting monthly meetups, personal in-person monthly meetups, and we did around 12 meetups in the year 2019, and we were hoping to continue the same in 2020 as well. But starting March, we were unable to do that, so we started this online meetup since April 2020, and we got a good response both in the terms of speakers as well as audience, and we are hoping to continue the same in the year 2021 as well. So let's start last talk of the year 2020. Let me add the today's speaker to the stream. Give me a moment, please. I hope everyone can hear me fine. Can you please put in comments if everyone can hear us fine? Okay, great. So we have Luke Downing with us today. He is a full stack developer from Derbyshire, England. He is a firm believer that happy developers make happy consumers. He contributes to open source and try to help others do the same. Currently, Luke is interested in Laravel package development, composer edge cases, and developer tooling. He works as a lead developer with Ricorox, which is a web agency specializing in event management and hospitality. So without further ado, I would like to hand over to Luke now. Luke, it's all yours. Go for it.
Thank you very much. Thank you everyone for being with me. Hopefully you can see my screen and everything should be okay from here on out. So yeah, my name's Luke Downing. Thank you for coming and spending one of the last days of 2020 listening to me. And as has been said, I'm a developer from Derbyshire, which is right in the middle of the UK. It's nice, there's lots of green fields and trees and grass, and the internet's not too bad either, so that's a bonus. I'm going to be talking to you today on a theme that's close to my heart, and that is thinking like a package developer. The talk consists basically of two parts. For the first 15 minutes, it's going to be a slideshow where I'm talking more at you than anything else. But it's important because we need to understand why package development is so important and why it's a big part of the Laravel ecosystem. But then for the second half of the talk, we're going to be building a package together live. So that's going to be quite fun. So sit tight and hopefully we can get through this in time. So there's this phrase that's thrown around often in software development, and that is decoupled code. You've probably heard of this expression. And it's quite self-explanatory, but we do tend to have this habit of using phrases in software development without really understanding what those phrases actually mean. So what does it actually mean to decouple our code? Well, to decouple is to separate something from something else that it was joined to or part of. But I want to alter that a little bit because you can also proactively decouple. So you can separate something from something else that it could be joined to or part of. So it's important to understand the distinction there. And an analogy I like to use to describe this is a train, right? So a train is this massive vehicle, and it's much longer than most of the vehicles in the world, but it's made up of lots of small carriages, right? Lots of small parts. And you can add or remove carriages from that train, and the whole thing still functions as a train. You can even add different types of carriages. So you might have a passenger carriage, but you could switch that out with a coal carriage and the whole thing would still be a train. In other words, lots of small pieces make one big thing. Just keep that expression in your mind. Lots of small pieces make one big thing. Decoupled code, or good code we could call it, is very much like that train. We should be able to add or remove features and entire feature sets without the rest of the application breaking down, with minimal impact on the code base. And that's really what decoupled code is aiming to accomplish. So what are some of the benefits when we properly decouple our code? What do we gain from decoupled code? Well, first of all, it boosts feature output. And I want you to note that I've crossed out the word code here. You are probably going to write less code when you decouple than you would if you were writing tightly coupled code. But what you will deliver are stable, beautiful, full-fledged feature sets that make a real difference to the application as a whole. So it's an important thing to note. It also prevents some of the most common bugs. So I don't know whether you've ever worked in a project and you change a line in the HTTP client and then something in the database layer breaks down. That bug is only caused by coupled code because the HTTP client and the database should know nothing about each other. So when those two things are properly decoupled, almost every obscure bug that can take weeks to figure out, they disappear. And you end up with not zero bugs, but certainly far fewer bugs. It makes automated testing simple. So I don't know whether you write tests for your applications or not, but if you do, and you really should, when you're in a coupled environment, you tend to have to write more workarounds and mocks than actual tests. And to go back to what we were talking about earlier, that HTTP client and that database, imagine if every time you called a HTTP endpoint, it hit the database. In your tests, you'd have to mock out the database just to stop that from happening. And what happens is your test becomes filled with dependencies rather than actual expectations and results. So when you look through your test suite, you can't actually understand what the tests are doing. It's unreadable. And this leads to one of two things. At best, you write fewer tests because those tests are harder to write. But at worst, you write no tests because you just can't see the value in spending that long world building and mocking out dependencies. On the other hand, when we deal with decoupled code, tests are easy to write. They're small because we don't have to create lots of mocks and lots of workarounds just to get a test to work. So automated testing becomes much easier with decoupled code. And it reduces cognitive load. This is a really important one to me. Have you ever come into a big legacy coupled project and, I mean, you don't even understand what's going on, right? And it might take months just to get a picture of what the code base is actually doing in your mind. But even then, it doesn't mean you're confident with the code. So instead of removing a class or a feature set that needs removing, you comment it out and hope that nothing breaks, right? Or rather than refactor a class that really could do with refactoring, it just gets left as this big, messy block of spaghetti code. And your mind has to work overtime just to make small tweaks. Something that should take 20 minutes can end up taking 20 days. Whereas in decoupled code, everything is easy to understand because each piece is only responsible for a single thing. And it does that single thing really well. So we don't have to understand the business logic of the entire application to understand what one class or feature does. I'll just say that again. We don't have to understand the entire business logic of the application to understand what one class or feature does. And all of these points add up to something that is often overlooked, but that is so incredibly important. And that is developer happiness. Let me explain why this is so important. Unhappy developers make poor quality code. That's not an opinion, that's a fact. If you are unhappy, you will not write your best code. And poor quality code creates bugs, which make more unhappy developers, right? No developer wants to sit fixing bugs. They want to write new features. But bugs also cause unhappy shareholders and unhappy business owners and unhappy customers. So what does that lead to? Well, it leads to stress, and as such, you get more unhappy developers. It's this endless vicious cycle where if we write in a decoupled manner, the code is structured well, it's simple and beautiful, it knows its boundaries, it's a pleasure to work with. And so it leads to high quality, easily maintainable, well-structured applications. And that makes for happy shareholders and happy business owners and happy consumers. And you get this awesome end product. And so you leave work at the end of the day or the week really pleased with what you've come out with. It's so important that you can be happy when you're doing your job. Now, why are we talking about decoupled code in a talk entitled How to Think Like a Package Developer? Well, the reason is, if you've not already grasped it, a package is decoupled code. It is really difficult to write a coupled package because it sits in its own entity. So unless you're writing terrible code, it's almost impossible to reach beyond the boundaries of the package. You don't know what application it's going to be installed in. And so when we start thinking in terms of packages, we also start thinking in terms of good decoupled code. So how do we define a package? Well, first of all, it has to be a self-contained feature or set of features. It has to be self-contained. It can't reach outside of its own domain. Instead, what we do is we allow hooks that give us a set of tools to extend the functionality that the package offers. Now, this is not to say that in a Laravel package, we can't use Laravel features. In fact, when we build the package that we're going to build in a moment, we're going to be making extensive use of Laravel features. But we wouldn't know anything about the application that the package will eventually sit in. Second, a package is designed to be used by developers. It is in no way an application. It's not for end users. It's not for consumers. Rather, it's a set of flexible, abstracted APIs to be used by people like you and me. In fact, you might even create a package where you are the only user of that package. It should still not be an end product. It's designed to be used by developers. It has almost 100% unit tests. And when I say this, I'm not referring to code coverage, and I'm also not referring to the amount of test code you've got versus the amount of application code you've got. I'm referring to the type of test. So a unit test is our lowest level of test, and it targets things like functions and classes rather than end-to-end features and processes. This kind of just highlights what levels our packages are. They are low-level packages. They provide abstractions over difficult concepts. Leave your applications to do the top-level work. And finally, it can work alongside other packages. So you remember that train analogy? Each carriage is its own thing, but each carriage also has a mechanism to allow another carriage to be attached. It's so important that you get that in your mind. We need to develop packages in such a way that other packages in the ecosystem can fit in without any difficulty. Now, of course, at some point, there is going to be a conflict of interest. But in as much as it is possible, we should be writing our packages in a way that allows other packages to sit alongside without issue. Okay, I think that gets in our mind the idea we're referring to when we talk about packages. So let's build something. I think the best way to demonstrate how easy it is to kind of flip the switch in our brain and start thinking like a package developer is to actually build one. And along the way, I'm going to be showing you tips and tricks that I have used and that really help me when I build packages. So here's the scenario. Your boss asks you to implement password breach checks. And the idea is that when someone registers for your site, if they try to use a password that has been recognized in a security breach, a published security breach, then they should not allow that password. Now, straight away, you can see that this is something that could be used across multiple projects. It's quite a generic thing. But even if you could only see use for it in one project, you should still very much consider building a package for it because of the reasons we've discussed earlier on. It helps us to write better code. In this case, we're almost certainly going to use it in more than one project. So we're going to be using the Have I Been Pwned API, and that allows us via a REST API to check if a password has been involved in a security breach. So if I can find the right application. Here's the documentation for the API. I'm going to walk you through it quickly. This is about packages, not about the implementation, but it's good to have a little overview of what we're going to be building. So you can see we can make a GET request to this API endpoint, and we pass the first 5 characters of our password hash. And the password hash is a SHA-1 hash, and it has to be UTF-8 encoded, right? And when we pass that hash, Have I Been Pwned is going to return a list of hashes that have been found to be compromised. So if our hash, our password hash, is in this list, it means that we have an insecure password. And that's the long and short of it. That's what we're going to be building. Now, before we do any code, I think it's important to talk about the API that we're going to use. Oftentimes, it's tempting to dive straight into the implementation without thinking about the end product, the end API for a user. So let's take a look at the API that we want to use for our Have I Been Pwned application, or Have I Been Pwned package. You can see here's my first iteration, right? I have this pwned facade and this password method, and I pass the password that my user has given me into this password method. And obviously that's going to return whether it's secure or not. Now this is okay, it technically works, but it's a terrible API to use as a human. First of all, what does this password method do, right? We have no idea. Does it encrypt? Does it hash? Does it make a HTTP request? Does it record something in the database? We have no clue. It doesn't tell us anything. So after reworking this a bit, here's another look. So this time we use the pwned facade again and we check if the password is safe. This is a lot better. We now can read this like a sentence. We can understand what this is doing, and perhaps even a non-developer could tell us what this is trying to accomplish. It's also open for extension. We could add new methods to this check object, such as perhaps is compromised or breaches, that returns an array of websites that the password's been breached on. And we can keep extending without having to modify the API too much. But there's still something that I don't like about this implementation, and that's this pwned facade. The word pwned ties the package down to the implementation that we're going to use. It kind of reveals that we're using the Have I Been Pwned API, when in actual fact we might want to use a different API, or we might want to use something local. So we shouldn't limit when we don't have to. And after a little bit more thinking, here's the API that I really settled on. You can see it's very much the same. We check the password is secure, but I've switched the facade out for this padlock keyword. I think padlock is a really nice option. Almost everybody knows what a padlock is, and it's very evident that a padlock is to do with security. Again, a non-developer could look at this and they would know that they're dealing with something that is to do with security. This whole thing reads really nicely. We wouldn't have to spend hours in documentation just to work out what's going on. And I think this is one of the most important things for you to do when you start developing a package or any API in your developing career. Write the API first, then create the implementation. It helps you to catch mistakes and assumptions early. It helps you to become familiar with the purpose and boundaries of the package. It helps us to understand how we might structure the package ahead of time. It allows us to make the correct abstractions, and it leads to a much more natural API, which means more time coding and less time reading the docs when using your package. So let's actually implement this API in a package. Now, as we develop, I'm going to be explaining things in as much detail as I can. I don't want you to think that I'm being condescending if there are certain things that you know. It's just that when I started developing packages, these are all things that I struggled with. So I want to share them with you in case you struggle with the same things. Creating Laravel packages does not have to be difficult at all. So I'm going to open up the project that I've created. And in order to save a little bit of time, I've created some boilerplate, but please don't worry, I'm going to run through all this now. The root of any Laravel package is the composer.json file. So let's open that up and take a look. When you run composer init on a new directory, it's going to generate this file. And the first thing I want to say is that name, description, type, and license and authors is all just metadata. It will not affect how your package works. So don't get tied up trying to work out what these values are going to be when you first start developing packages. The ones that are important are these 4 keys here: require, require dev, autoload, and autoload dev. And you might be familiar with them, but you also might be scared of them. And I think the reason is that Laravel is just such an awesome framework, right? It's so good, and it comes with such good defaults that you barely ever have to touch your composer.json file, which can lead to not quite understanding the tool that we're working with every day. So don't worry, I'm going to break these 4 very important keys down for you now. Anything in this require key object is going to be a dependency that your package relies on. Any project or package that we require here will also be installed in the application that this package is installed in. So imagine if you create this package and then you install it. Well, your application's vendor directory will include these requirements. So here we require Illuminate support, which is basically the Laravel framework. If you're creating a Laravel package, you need Illuminate support. And you can see that we're targeting Laravel version 8.2 and greater. Now, what do we do if, say, Laravel 9 comes out and we also want to add support for Laravel 9? Well, Composer allows us to do the pipe operator to specify multiple supported versions. So we could also say it's greater than 9.0, and you'll be able to use version 9.0 as well. Now, obviously, Laravel 9.0 isn't out yet, so let's remove that for now. You'll notice that I also require Guzzle, which is a HTTP client. The reason I'm doing that is that the Have I Been Pwned API will be using the Laravel HTTP client, which itself relies on Guzzle. So we have to install that as a dependency. Require dev is the next key. This is very similar to require with one key difference. Any dependencies required in the require dev object will not be installed in the application. They will only be installed whilst you're editing the code in your package. So if I drop my vendor directory down, you can see I do have the Orchestra test bench directory. And you'll also see that I have the pest PHP pest plugins expectations that match these 2 dependencies I've required. But when I install this package in an application, those 2 folders will not be there. Now, why have I required these 2 particular packages? Well, Orchestra Test Bench is a wrapper over PHP unit, which is our testing library, and it allows us to write Laravel tests. So if you've ever written an automated test and used this get or this put, then you're using Orchestra Test Bench. So we need that to be able to write Laravel tests. I also bring in the pest PHP plugin expectations. Pest PHP, if you don't know or are not familiar, is another wrapper on top of PHP unit that allows you to write tests more as closures rather than classes. Now, we're not going to be using pest PHP in today's talk, but this plugin allows us to write awesome expectations and assertions, which you'll see in a moment. It's super clean. So that's why I've required it here. We also have this auto load key. Now, this is perhaps where you start getting scared. You've used require before, but maybe you've not touched auto load much. Or maybe if you have touched auto load, everything's broken and you can't figure out why. Auto load is just a specification that describes how classes and files can be automatically included in PHP based on their namespace. And you'll see that the first thing we include in this object is PSR4. So PSR4 is just a standard set down by the PHP body. And if we didn't have standards, obviously nothing would work on the web. So it's a good job they've done that for us. But there are multiple different standards. There's also PSR0. So we want to specify that we're using PSR4 here. Every key and value in this object is going to be a namespace that relates to a directory in our project. So here we have the source directory. Hopefully you can see that in our Finder. And everything in the source directory is going to start with the namespace Luke Raymond Downing padlock. You'll note that we've got double backward slashes here. That's basically because we're working in a string, and a backward slash in a string is a special character. So we have to escape that special character with another backward slash. Now take a look at this autoload dev object. This is very similar to the difference between require and require dev, but for autoloading. So anything defined in this PSR4 object will be included whilst we're developing directly on this package. So whilst we're editing code in the package, but once we require it in the application, these namespaces won't exist. So it's a perfect use case for things like tests. We want to be able to namespace and access tests while we're working on the padlock package itself. But once it's installed in an application, we're no longer bothered about accessing those tests. We don't need to run the package tests in our application. Something a little more advanced, but just as useful, is for mocking out namespaces that exist in Laravel that you don't have access to in the package development environment. So for example, I have some stubs here that I want to publish to the application, and I can use the app namespace in autoload dev to pretend that these are already inside the application in my tests. That's super useful. If you don't understand what that means, it's okay. But if you do, you can hopefully see the power that that would offer you. Okay, enough of composer.json. Hopefully we can come back here later and add a couple more things to give our project superpowers. But for now, let's go to testing. You'll notice I've included this phpunit.xml file. Again, this is something that Laravel provides great defaults with out of the box. So if you've only ever developed in the Laravel application environment, you may never have had to create a phpunit.xml file. But this is how simple it can be. We basically tell phpunit where our autoload file is, and hint, it will basically always be in the same place. And you can see I've set this property colors equals true. It just means that when we're running our tests, we get some nice red and green depending on if our tests fail or pass. We also have this test suites array of nodes. Each item in this array is a location in our project where tests can be found. So we only have one place, and I would suggest keeping your tests in the same place. You'll notice that we say any file in the test directory, which is here, that ends with test.php should be classed as a PHP unit test. So any test in the test directory where the class name ends in test.php contains tests we want to run. Okay, let's jump into one of those tests, and it's going to be this padlock facade test. This is where we're going to spend most of the rest of the talk, kind of jumping back and forward. And this is what's known as test-driven development. I've not written any implementation code yet, but what I've done is created two tests that will prove our code works when these two tests pass. It's a really powerful way of working, and you should definitely give it a try if you've not already. So you can see here, we have our final API, right? If I switch back to Tinkerwell, padlock check password is secure. And now back to PHP Storm. You'll see that there our API is, right? So if this passes, we finished our API. We have a working package and a working API. So we're going to say, well, check the password is secure. And obviously the password is a terrible password. So we would expect that to be false. But if we check this long complex password is secure, well, then I would expect that to be true, right? I'd expect that to be secure. So what we can do is run these two tests, and I'll minimize that a little bit. And you'll see that we failed both tests, right? But we got a reason for that failure. The facade padlock wasn't found. Well, obviously, we've not started our implementation yet. So you'll see in my source directory, I've created 4 directories. And I like to kind of try and set my structure up before I start working. And again, if you've decided on an API beforehand, you tend to be able to do this. So in this facades directory I've created, let's create a new class called padlock. And obviously, being a facade, it needs to extend Laravel facades. Let's run our tests again. And now we get a different error. Facade does not implement get facade accessor method. So again, perhaps if you've only ever worked in the Laravel application environment, you've never had to create your own facade. And that's not always the case, but often you can get away with what already exists. In this case, we want to write our own facade, so we will override the getFacadeAccessor method. And all this expects is for us to return a key that can be resolved out of the container. And I'll explain what that means in a moment. But I'm going to return the string padlock and rerun our tests. And you'll see that it's going to tell us that the container could not find that key padlock. So the Laravel service container is just this awesome way of applying dependency injection and dependency inversion to your applications. It is super powerful, and if you don't quite know how it works, go and look at the Laravel docs. The author of Laravel, Taylor Otwell, has recently gone and revamped all of the documentation for Laravel, and it's super clear now. It's so easy to understand how it works. So go and read through it and get your head around the service container and how everything works. The service container receives its bindings via service providers. So we're going to create a service provider now. And obviously, it would be good to call it the padlock service provider. One thing to note is that all of my subdirectories in this source folder start with an uppercase letter. And that's because they are an extension of the namespace that we defined in our composer.json file. So you'll see that this providers directory has a provider's namespace appended to it. So it's important that you use uppercase for those directories. Again, obviously, being a service provider, it should extend the service provider that comes with Laravel. And in there, we have a method called register that every service provider has access to. And this is where we bind things into our application. So I can use this app, and because it's a facade, I want to bind a singleton. Let's remember what that key is that we used, padlock as a string. And we want this to point to a class that is going to have our methods on it. So let's create that class, and because it's going to be the core of the entire project, I'll create it at the root of the source folder. We'll call it padlock. Let's switch back to our service provider, and let's reference that class name. Run our tests again, and oh, we got the same error. Now, the reason for this error is that our tests do not know about this service provider. Remember, we're not working in a Laravel environment here. We're working in a completely separate environment, and we're tricking it into thinking we're inside Laravel. This is where Orchestra Test Bench comes in. If we go back to our test class, you'll see I extend this test case, which is just this class I've created here. And this class extends Orchestra's test case. So you'll probably want to do this in every package you create some base test case, and you're familiar with this from Laravel anyway. Laravel has a base test case that you can alter and change. And there's a method you can override called getPackageProviders. Anything you return in the array that you should return from this function, any service provider you return in that array will be loaded as a provider for your tests. So you can see here that I can return the padlock service provider. If I run my tests again, the error should change. And indeed it did, which means that we have successfully bound our facade to our concrete class. Now you'll see the error now says, well, there was no method called check on the padlock object. So let's go ahead and create a public function called check. And if you remember our API, we pass a password to that function, right? So we'll switch back and we'll pass a password to that function. Run our tests again. It now says, well, there was nothing called isSecure. Back to our API, of course, we're going to chain a method on called isSecure, but at the moment, check is returning nothing. So I'm going to create a class in this password directory that I've created called password lookup. And in there, let's have a function called isSecure. Obviously, this class is going to need to know the password that we want to use. So in the constructor, let's require that you pass a password. And if you're wondering what this is PHP 8. So because our package is targeting PHP 8 and above, we're able to use this syntactic sugar to say, well, we're going to pass a password in, and we want it to be a class property. So that's really useful, a little shortcut for us. Of course, now if we go back to our padlock class, we can just return a new password lookup, and we'll pass it the password. run our tests again. Okay, the message changed, but we're getting very close. Let's go back to the password lookup class we just created. And I bet now if we return a Boolean from here, one of our tests will pass and the other will fail. And indeed, that's the case. That means that we're at the point where we would want to implement the Have I Been Pwned API. Now, we could implement the Have I Been Pwned API directly in this function, but I want to go through something that will be altogether better. It's going to take a few extra minutes, but it will be well worth the effort. So what I will do is in this contracts directory, I'm going to create a new interface called Sentry. And the reason I've called it Sentry is because Sentry is a great name for anything that acts as a guard, right? And we're dealing with passwords, so that makes sense. The reason I've called this directory contracts is that that mirrors what a lot of the Laravel ecosystem does already. So Laravel itself has a contracts directory, and many of the first-party packages have a contracts directory. Whenever you can follow the tradition that Laravel sets out, you should try to, because it's been thought about for a long time, and any developer using your package that is already familiar with Laravel will become instantly familiar with your package. Remember, it's all about developer happiness. So in here, let's have a public function called isSecure, and we pass it the password, and we expect it to return a Boolean based on whether the password is secure or not. In our password directory, I'm going to create an implementation of this, and it's the Have I Been Pwned API. So Have I Been Pwned, and it's going to implement that Sentry interface. And of course, that needs to use the isSecure method in order to conform to it. Now, this is not a talk necessarily about Have I Been Pwned, but it's such a simple API that we're going to implement it live. So the first thing I want to do is when I receive this password, I want to turn it into the hash that Have I Been Pwned expects. If you remember from the documentation, that's basically going to be a matter of SHA-1 hashing it and also UTF encoding it. Now, if I switch back here, you can see that the results are all uppercase. So it would be wise at this point to uppercase this string. So we'll use the string helper for that, and we'll just uppercase it. So our hash is now ready. It's time to make the request, right? So let's make a protected function called makeRequest. And we're going to be using the HTTP client. It's a GET request. And again, let's switch back to here, and we'll grab this URL. And let's paste that in there. And we need then to add the first 5 characters of our password hash. So I'll use the substring method for that, pass in the hash, and we want offset of 0 and the first 5 characters. Okay, so we make a GET request to this endpoint, passing the first 5 characters of our password hash, and we're going to want the body of that request. Back to our isSecure method, we need to call this, right? Let's return, and if the body contains our hash, that means that it's insecure, so it's the opposite of that. So if string contains, we'll make the request, and then what are we searching for in that body? Well, we're searching for a substring of our hash, and we want to offset it by 5 to get rid of the first 5 characters. I think that is the entire implementation done. That should actually work. Obviously, if I run the tests again, nothing's changed because we've not told our package about this implementation. So let's go do that now. In our password lookup, we'll change this return true to return the Sentry as resolved from the container is secure, and we'll pass this password in. If we run the tests again, they're both going to fail. And we've got a very similar error to what we had earlier in this talk. So the container doesn't know about Sentry. Let's go back to the padlock service provider and let's add another binding. So we're going to bind the Sentry interface, and anytime you ask for the Sentry interface from the container, we're actually going to return have been pwned. Okay, let's run the tests again. And we have 2 passing tests. That means that we have successfully implemented have I been pwned in a package. Now, that's well and good, but what if a user doesn't want to use have I been pwned? What if they want to run their own version, right? What if they want to create their own driver that conforms to the Sentry interface and use that in their package? Well, because we've written in this manner, and because we've got tests backing us up, we're able to make this change very easily. So you'll notice at the top of my structure here, I've created a config directory and a padlock.php file. You're probably very familiar with config files. They're everywhere in Laravel. So you've got app.php, auth.php, database.php. All of those config files allow you to change how Laravel works. And packages can provide config files to do the same thing. So all it has to be is an array. It returns an array. And in that array, we're going to follow Laravel tradition once again, so that our developers feel at home and can be happy. We're going to have a key called default. And let's allow the user to declare an environment variable called padlock provider. But by default, let's say it's going to use the have I been pwned API. Now let's create a providers array. And in that array, we want to define the provider that comes out of the box with our package, which is have I been pwned. In that have I been pwned array, we want to point to the class that conforms to the Sentry interface, which is have I been pwned as a class. And we can clean that up by importing the namespace at the top. Okay, that is our config file done. Let's go back to our service provider and switch this hard-coded have I been pwned implementation for dynamic content from our config file. So the first thing we want to do is load the default that is set. So we'll say provider equals, and we'll use the config helper method, and we'll load padlock.default. And then rather than hard coding have I been pwned here, let's change this for a call to the config helper method. And we'll load in padlock.providers. And then we want to use the key that came from our default config. And then we want the driver key. Now, if we run this test again, it's actually going to fail. The reason is that we've not explained to Laravel how to load our default config file. This is something, again, that if you've only ever worked in the Laravel application ecosystem, you won't be familiar with. But there's a method on every service provider called merge config from. All we have to do is point to our local config file. So here I go. Here's padlock.php. And the second parameter is the key that we want to use to access anything in that config file. So you can see we access it with padlock here, and we access it with padlock here. So we're going to use the same here. Let's run our tests again. And they're back to passing. But what's even better is that a user would now be able to go and configure a new driver without any extra work from us. They could make our package behave however they wanted with very little work. But how do they actually access this config file to edit it? Obviously, we can't just leave it in our package. We need to publish it to their application when they install our package. Well, for that, there's another method in service providers called boot. This runs after every register method in the application has been run. And what we can say is, if this app is running in a console environment, we will make the config file available to publish. So to do that, we again need to reference the location of our config file. And we point that key to a value that is the location you want to store that file in the application. So there's an amazing helper method called config path. And obviously we want to call it padlock.php. Now, when the user runs a command like this, php artisan vendor publish, our config file will become available for them to publish. I want to be able to specify that we want to publish padlock assets rather than making them choose from the long list that will appear when they run just vendor publish. And to do that, it's as simple as adding one extra variable, which is going to be padlock, to the end of this publishers function. Now, when the user uses our application, they can run this command from inside their application, and they will see our config file appear in their config directory. And because we've used this merge config from command, anything that doesn't exist in their config file, the application will fall back on our default. So it's such a powerful way of working. And because we've designed in this way, we've made our package configurable for users. There's so much more I want to show you, and I'm going to show you how you can see all the extra stuff at the end of this presentation. For now, let's switch back to Keynote. I want to review what we've gone over. When you're working, look for ways to split down applications into reusable feature sets. You are going to be working in Laravel applications most of the time. So when you are doing that, think before you start implementing a feature, just stop and think, can this be a package? And what are the benefits of it being a package? Go and gather some inspiration from packages that already exist. There are so many amazing packages out there, but some of the best are the first-party packages from the Laravel team themselves. So go and look, like, how did Taylor introduce publishing, right? How does Taylor mock the database in his packages? How does he test models in his packages? You go and look through the source code, and there is so much information that you can make use of to improve and pretty much do anything that you can do in a Laravel application inside a package. Here's a dead ringer, right? If you ever need to copy code from one project into another project, take the extra 5 minutes to write the boilerplate and build a package. Because when a third project comes along that you need it for again, it's a Composer install away. On that note, get confident with Composer, especially autoload. So many developers aren't familiar with the tool that we use every single day in our applications. So go read the documentation, look at what all the different keys available to you are. Think about why you'd want to use them in package development. When it comes time to host your packages, packages.org is the way to do it. It's free, it's open source, and everybody will be able to download your package to use in their application. Now, obviously, that doesn't fit every use case. You might be creating a package for a company or even a private package for your own use, in which case I can recommend repman.io. It's very similar to Packages. It's also completely free, but it allows you to host private packages. And all you have to do is add a little configuration to your composer.json file. Here are some links. The main one is this padlock repo. It's already available on GitHub at luke-raymond-downing/padlock, and it contains tons more than we've had time to put in today. So for example, how do you mock the database? How do you pretend that you're working with models and migrations? How do you cause those migrations to be seeded when you run your tests? How do you create hooks that the application can use to extend the functionality provided to you by your package? All of that is there. There's full test suites for the entire thing, so you can look through the tests and see exactly how it's all put together. And I've tried to make it as simple as possible. You can also find me on Twitter. I'm at LukeDowning19. I'd love for you to come and follow me, but even if not, just come and chat. I'd love to talk tech, and any questions you might have in the coming weeks about package development or Laravel in general, I'd be happy to discuss. I also have a blog, downing.tech, where I infrequently post things, but when I do, I try to make sure they're high quality content. So you can go and look there and see what interests me and what I'm currently working on. But with that done, I think I just want to say, if you have any questions, I'd be more than happy to take them. So yeah, if you've got any questions, please don't hesitate. Feel free to put them forward.
Thanks a lot, Luke. It was a wonderful session. I'm sure everyone learned something new today, including me.
You're
So
very
let's
welcome.
wait for people to ask questions.
Yeah.
Okay, I'll start with myself, Luke. So I have a question for you. Would you recommend developing each and every project, client project, using packages, or what is your criteria to determine whether to go with packages or build it as a normal application?
That's a good question. So in projects that we've worked on, it's kind of when there is something at the core that we don't like. So recently we had to integrate with a SOAP API, and when you've worked with the HTTP client in Laravel, like working with SOAP APIs again is just disgusting. So rather than just diving straight into using the default SOAP implementation, we created a package around SOAP, and that's obviously made developing with those SOAP APIs so much nicer. So that's one area, but another area would be just when you stop and think, like, is this specific to the application? If it's not specific to the application, it could very well be a package because it will likely fit in another application.
Yeah, especially because even we have seen that what we generally do is there is some piece, some feature or piece of code that we repeat in each and every project that we build for the clients. So I believe it is better to extract it into a package so that it is reusable.
Definitely, yeah, absolutely.
Yeah. Any other questions from our audience? Okay, so look, we have a question from Yash.
Mm-hmm.
How can I install package without register on any package service? So I believe what he's asking is he doesn't want to upload the package to Packagist or Repman or anywhere. In that case, is there a way we can develop a package for local consumption or consumption in our own projects only?
Yes. So you can use, again, using the composer.json file, which is why it's like so important that you look that up and understand how Composer works. You can use a repositories key to state a local repository, and you can literally provide a path that is symlinked in the application to that local repository, which would be your package. Obviously, once you want to go live with that, you need a way to host it somewhere. But there are applications. Composer themselves provide quite a low-level package called Satis, S-A-T-I-S, and that allows you to publish or host packages on your own servers. Again, the reason I recommend something like Packagist or Repman is that it takes the complexity away. But if that's not possible, you can host your own, basically your own Packagist. Oh, I think you might be muted, Abbas.
Sorry, yeah. Yes, I hope Luke was able to answer your question. So anyone else has any questions? Let's see. We'll give just 30 more seconds, Luke, and then we'll call it a day.
Mm-hmm.
In the meantime, I would like to thank all our audience who attended today's meetup. Thanks a lot for joining, and I hope you'll keep joining us each and every month. Also, as mentioned earlier, we are constantly looking for speakers. So if you're interested in speaking in our next meetup, please submit your talks at the URL that is coming up on your screen right now. You need not be you need not be a seasoned speaker. We welcome first time speakers as well. So please don't feel shy and submit your talks. Okay, I think that's it. Thanks a lot, Luke, once again.
Thank you. That's been awesome.
Thanks for listening. And hope to see you soon. Once again, maybe in the year 2021.
Brilliant. Thank you.
Thanks. Thank you, everyone. Have a good night. Bye bye. Cheers.